Hello, Algebra 2. Today we're going to be continuing our unit in rational expressions, and the topic today is going to be simplifying rational expressions through factoring. So if we remember, and let's remember fractions, if we were simplifying fractions like 3 over 6, we could simplify that down to 1 over 2, correct? We found a common factor in each one, 3. 3 goes into 3 one time, and 3 goes into 6 two times. So just like we can simplify a fraction that involves integers, we can also simplify a rational expression that involves polynomials. So let's go through an example here of 27x plus 27 over 45. And we want to simplify this. So we can look at our numerator here and automatically see that we could factor out a greatest common factor in our numerator of 27. So let's go ahead and rewrite that. If we pull the 27 out of our top expression there, we would get x plus 1. Factoring the 27 out of 27x leaves us with just x, and then of course factoring 27 out of 27 leaves us with just 1. Now that is still over 45. Now if we look at our numbers here, we can reduce this fraction of 27 over 45. They each have a common factor, and in the common factor, the greatest one in each would be 9. So how many times would 9 go into 27? It would go in 3 times, and how many times would it go into 45? It would go in 5 times. So we reduce that to 3 over 5. So we'd be left with the expression 3 times x plus 1 over 5. And that would be the simplified version of our original rational expression here. Let's go through a second example like that where we're pulling out a common factor. And another example would be 30 over 50x plus 50. Okay, so again, right away we can see we can pull our common factor out of our denominator here, and that would be 50. So we can rewrite that as 30 over, if we pull 50 out of our expression here, we'd be left with x plus 1. Okay? 50 goes into 50. If we pull 50 out of 50x, we're left with x, and 50 divided by 50, of course, is just 1. Now we can reduce our fraction here, 30 over 50. Each one shares a common factor of 10. 10 goes into 30 10 times, goes into 55 times. That would leave us with 3 over 5 times x plus 1. And so there's two examples on simplifying rational expressions using a common factor. Now what if we have trinomials? I'll give you an example of that. We had x squared minus 6x minus 27 over x squared plus 4x plus 3. Let's say this is our rational expression, and we were instructed to simplify this rational expression. So we have to go back to our last unit and remember factoring trinomials. So let's just take it one piece at a time. We're going to look at the numerator first and then the denominator. So let's factor this numerator. We need to find two numbers that when multiplied together give us a negative 27, and when added together give us a negative 6. So that would be x minus 9, x plus 3. So hopefully you remember the factoring unit. Okay, we found that number, negative 9 and a positive 3. When we multiply those together, that does equal negative 27. And when we add negative 9 and a positive 3 together, that does give us negative 6. So we successfully factored the numerator. Now let's factor the denominator. We need two numbers that when multiplied together give us positive 3, and when added together give us a positive 4. That would be x plus 1 and x plus 3. Okay? So now we successfully factored the denominator. Okay? Well, now we can simplify this. Okay? If we're multiplying by the same thing on top as we are on the bottom, those cancel out. So this x plus 3 cancels out, top and bottom, and we are left with x minus 9 over x plus 1, and that is our simplified version of our original expression here. Okay? So let's do one more where we're factoring trinomials. Okay, we'll look at r squared plus 8r plus 12, and that is going to be over r squared minus 2r minus 8. So we have a trinomial over a trinomial, so we're going to try factoring these. Let's just look at the numerator first. We need two numbers that when multiplied together give us 12, that when added together give us 8, and those would be 6 and 2. We multiply 6 and 2, we get 12. We add 6 and 2, we get 8. So we have r plus 6, r plus 2. That is our factored numerator. Now let's factor the denominator. We need two numbers that when multiplied together give us negative 8, and when added together give us negative 2. That would be r minus 4 and r plus 2. Okay, negative 4 and positive 2, when those are multiplied together, give us a negative 8, and negative 4 plus a positive 2 give us a negative 2. So that's our factored version of our denominator. Now we can look, again, we have r plus 2 on the top, r plus 2 on the bottom, those cancel out, and we would be left with r plus 6 over r minus 4, and that is the simplified version of our original rational expression here. So you'll have, on your homework, you'll have 4 problems where you are factoring out the common factor, like we did in our first 2 examples, and you'll have 6 problems where you will be factoring trinomials like this and canceling out common factors here. So if you have any questions, please email me. Go do your homework.